Find x. What I have is a triangle, that is a right triangle, and I have two other right triangles living inside this. Now, there's a way that you could set this up and solve it using proportions, but I'm going to show you a different trick called the geometric mean. You may have heard of the arithmetic mean. This is the geometric mean. If you are given a big right triangle and you have the altitude and your job is to solve for the altitude, and that's what I have here. If I were to take this triangle that's 100 whatever's long and lay it flat, okay, like that, I can see that x is my altitude. What I know is one of those lengths is 36. Now let's take that out, pretend like we don't know that. Let's pretend we don't know any of this stuff, all right? Get rid of these numbers. Okay, there is a little shortcut using the geometric mean. If you are trying to find the altitude of a right triangle, what you do is you label part of this hypotenuse A and the other part B. The altitude splits it. And you set up a proportion A over x equals x over b. That's the geometric mean. Now, I have something very, very, very similar. I have one of these guys is 36. I showed that over here. I don't have the other guy, but what do I know? I can find the other guy by doing 100 minus 36, which is 64. So I would let A or B, it doesn't really matter because you're just going to end up doing crisscross applesauce anyway. I'll say 36 over x equals x over 64. Now that I have a proportion, I can do crisscross applesauce. Multiply two diagonals together, x squared, and multiply these diagonals together. That gets you 2,304. Take the square root of both sides because that's how you undo a square. Now, usually you attach a plus or minus to your number here. However, I'm not going to do that because that implies you're taking a negative side length, which doesn't make sense. What I do get is the square root of x squared is x. And the square root of 2,304 is 48. I knew that right off the top of my head. Didn't use a calculator. Didn't use a calculator at all. But this is using geometric mean. There's other ways that you could do this by using similar. I mean, if I wanted to, I could rip this apart and pretend that I have a small triangle and a big triangle and do similar triangles like I've done 1,000 times on this channel. But here I'm doing geometric mean to show you something new.